Okay, so finding density from an FCC or BCC lattice constant. So what you're aiming for is going to be a density in terms of grams per centimeter cubed. Remember, because density is mass over volume. So usually the units we use for chemistry would be grams per centimeter cubed or grams per milliliter. So for this question, I'm pretty sure you're being asked in terms of grams per centimeter cubed. So the key thing is looking at what kind of unit cell you have, because your approach is going to be to work out using the molar mass, the mass of 1 mole of unit cells. So you have to know how many atoms there are per unit cell. And then once you have that, you're just going to convert the mass of 1 mole of unit cells to the mass of 1 unit cell. That's using the Avogadro number. So remember, the Avogadro number is 6.022 times 10 to the power of 23 per mole. So those units per mole could be particles per mole, atoms per mole, ions per mole, unit cells per mole. Take your pick. Okay, so the only difference, things that can change in this question, is whether it's a face center cubic or a body center cubic unit cell. So you need to be able to count how many atoms per unit cell there are based on cell type, and of course the units of the lattice constant could be picometers, they could be nanometers, they could be angstroms, right? So you're going to need to get to centimeter cube. So you're going to have to remember some basic stuff from Gen Chem 1 that you've got to be careful of unit conversions when you've got a cube. For example, you could say, okay, so 1 centimeter is 10 to the power of -2 meters, for example. That's your conversion factor. But if you're looking at 1 centimeter cubed, that's 1 centimeter, and the cubed is outside the bracket, right? So that would be 10 to the power of -2 meters cubed as well. So what that means, if I can find my little button, is 1 centimeter times 1 centimeter times 1 centimeter. Of course, that is just 1 centimeter cubed, but then you've got 10 to the -2 meters times 10 to the -2 meters times 10 to the -2 meters. So this is where you have to be super careful, okay? Because 1 centimeter cubed is not 10 to the -2 meters cubed. It's 10 to the -2 times 10 to the -2 times 10 to the -2 meters cubed. Okay, so let's look at this particular problem then. So first of all, we're told it's a face-centered cubic unit cell. So face-centered cubic means it's got an atom on each corner and 1 atom in the center of each face. So there are 8 corner atoms. Each corner atom contributes 1/8 to the unit cell it's in, okay? And then we're going to add to that each of the faces. There's 6 faces on a cube. Each face atom, half is in one cube, half is in the neighboring cube. So 8 times 1/8 plus 6 times a half. I should probably put parentheses in if I don't want my calculator to hate me, right? That is going to be a total of 4 atoms per unit cell. FCC unit cell. If we were to do the same for a body-centered unit cell, right, there's just the 8 corner atoms, so 8 times 1/8, and then there's 1 atom in the body center. So 8 times 1/8 plus 1 gives me 2 atoms per BCC unit cell. So first of all, we're going to work out the mass of 1 mole of unit cells. So we're going to have to look up whatever the element is. It's iron. Iron in the periodic table that I'm looking at has a molar mass of 55.85 grams per mole. So we've got 4 atoms per unit cell times 55.85 grams per mole, the molar mass of iron. Your ALEKS periodic table might go to a few more sig figs than the one I'm looking at. Okay, so that's going to come out to whatever that is. Again, I might not be working to the same number of sig figs as you, 223.4 grams per mole. Okay, so that is 1 mole of unit cell. If we want to have just the actual mass of a single unit cell, 1 unit, so we're going to have to divide by the Avogadro constant. So it's going to be the 223.4 grams per mole divided by Avogadro's, which is 6.022 times 10 to the 23 per mole. So the per mole is going to cancel out. So again, dimensional analysis is usually going to help you out with these kind of things if you're like, so that's going to give me a mass in grams. Sweet. I am already halfway to my density. I don't know what that turns out to be. See if my calculator loves me today. To the power of 23. Please love me. Should be like a really small number. Yep. So 3.7 something 7, 1 times 10 to the power of minus 22. Again, I do not have anywhere near the sig figs that I probably should, but I'm just using a little handheld periodic table. So that is a mass in grams, right? So now I just need to get my volume. How do you get the volume of a cube? You multiply the sides of the cube together. It's a cubic cube, so all the edge lengths are the same. So my volume is going to be A cubed, right? So A cubed is going to be, what was it? 0.352 nanometers times 0.352 nanometers times 0.352 nanometers. That is going to give me nanometers cubed, okay? So I'm going to have to convert nanometers into meters, and then I'm going to have to convert it into centimeters because I want density in grams per centimeter cubed. 1 nanometer is 10 to the power of minus 9 meters. Where did that go? I thought so. 1 nanometer is 10 to the minus 9 meters, and 1 centimeter is 10 to the minus 2 meters. So that is the information we are going to need. So I guess I could do the 0.352 times 0.352 times 0.352. Hopefully I did that in my calculator correctly. So my volume is going to be 0.0396 blah blah blah, whatever it is, nanometers cubed. So convert that to meters cubed. I need to do on the bottom 1 nanometer times 1 nanometer times 1 nanometer. It's going to get messy real quick. And then on the top, it's going to be 10 to the 9, 10 to the minus 9 meters times 10 to the minus 9 meters times 10 to the minus 9 meters. Use parentheses liberally, please. So that would be my correct conversion. If I press equals right now, I have converted into meters cubed. I do not want meters cubed. I want centimeters cubed. So I've got to do 1 meter cubed times 1 meter cubed times 1 meter cubed on the bottom. Sorry, 1 meter times 1 meter times 1 meter gives me 1 meter. I'm getting a bit excited here. And then on the top, centimeters. So 10 to the minus 2. Hang on, I've done that the wrong way around. That's talking. That's talking. I want to get rid of my. No, I'm fine. 10 to the minus 2 meters. Centimeters should be. It's the wrong way around. 10 to the minus 2 meters. I really shouldn't talk and type. Times 10 to the minus 2 meters times 10 to the minus 2 meters. So that meter is going to cancel out, and then it'll just be 1 centimeter times 1 centimeter times 1 centimeter on the top. Okay, so sorry that looks kind of ugly, but I wanted to type it all out so you know how to make your calculator happy. When I stick that in my calculator, hang on, I get, it should again be a very small number. It should be about the same order of magnitude, give or take 1, as your mass in grams turned out to be, because density, what kind of range is density in grams per centimeter cubed? It's going to be like between 0 point something and, 15, 20, like, well, I mean, it's going to be like normal numbers, not like to the minus blah, 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 blah. I get 3.52 times 10 to the power of minus 22 as well. Is that right? I'm going to have to check these numbers are going to be okay. I'm going to just pause that a second to make sure my because this takes too long for me to type it into my calculator. Okay, so getting on my calculator, I realized I must have made a bit of a finger fudge error there. Actually, not on the bit you'd think, but on the 0.352 times 0.352 times 0.352, somehow I must have typed one of those in wrong instead of writing 0.352 cubed like a normal person would, and that should be 0.0436 nanometers cubed. So let's fix that and then multiply by 10 to the power of minus 9 times 10 to the power of minus 9 times 10 to the power of minus 9, then divide by 10 to the power of minus 2, 10 to the power of blah, 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 blah. That then does not come out as this. I knew that would kind of look funky. What that comes out to be is to 3 sig figs, 4.36 times 10 to the power of minus 23 centimeters cubed. Okay, so my units have cancelled out properly. Nanometers cubed is cancelled, meters cubed is cancelled, leaving me with centimeters cubed. So now I can go back to density equals mass over volume to calculate my density, and I am like totes running out of space here. So what am I going to do? You know what? I'm going to do it up here because I think we're done with that bit now. Okay, so my density is going to be my mass, which was 3.71 times 10 to the power of, where did it go? Minus 22 grams divided by my volume. Again, you may need to be careful with parentheses, which I finally got is 4.36 times 10 to the power of minus 23 centimeters cubed. Okay, so my unit should come out in grams per centimeters cubed. And I got to 3 sig figs, 8.509 17 blah 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 grams per centimeter cubed. So to 3 sig figs, that's going to be 8.51. Okay, so that is how I would do that one.